Hello, welcome to Chapter 4, Homework Questions 110 to 115. Question 110. When he was in first grade, Harvey played games with spinners. One game he especially liked had 2 spinners and several markers that you moved around a board. You were only allowed to move if your color came up on both spinners. Part A. Harvey always chose purple because that was his favorite color. What was the probability that Harvey could move his marker? Alright, so purple on the first spinner has a probability of 1/4, and then on the second spinner, looks like they're all broke up into thirds, so that's 1/3. So the probability that it would happen for both would be 1/4 times 1/3. Think of that area model, and that would be 1/12. Is the event that Harvey wins a union or an intersection of events? And this would be an intersection of events. It has to happen for both of them. It has to land on purple for both for him to be able to move his marker. Was purple the best color choice? And explain. And if you look at it, yellow has half of the spinner on the first one. And all of these down on the second spinner are a third. So the better color choice would have been yellow for Harvey. Part D, if both spinners are spun, what is the probability that no one gets to move because the two colors are not the same? So on this one, we could look at it as what is the probability that you would get to move and then take 1 minus that. So for example, we already know purple is 1/12. Yellow is 1/2 times 1/3, so that's 1/6 they would win. And then the only one we didn't do was green, that's 1/4. And 1/3, so that would be 1/12 as well, similar to purple. So plus 1/12. And if we add all of those up, we get the fraction 1/3. Now that's the probability of winning. So to not be able to move, we would take 1 minus 1/3. And the probability of not being able to move would be 2/3. Part E. There are at least 2 ways to figure out Part D. Discuss your solution method with your team and show a second way to solve Part D. So the way that I showed it on Part D was the complement. I found out the probability that it would happen. I took 1 minus that, and then that gave us 2/3, which would not. So to do it the other way would be able to figure out when it would not work. So for example, if I have yellow spun on the first one, then I would either have to spin a green or a purple for it not to work. So that would be 1/2 times, and since these is 1/3 plus 1/3 would be 2/3, I would take 1/2 times 2/3. So 1/2 times 2/3 is 2/6. And then go to the next one. If I have a green, then I would have to either get a yellow or a purple, and so that would be 1/4 times 2/3. So plus 1/4 times 2/3, and that would be 2/12. And then if I did purple, then I could get a green or a yellow, and it's still the same thing. 1/4 times 2/3 is 2/12. So then when I add all of that up, that would give me, 8/12? And if I reduce that by 4, that would be 2/3. So we could either figure out, like on Part D, where I figured out what the probability was to win and then subtracted 1 from that, or we can just figure out what the probability is not to win. Question 111. Consider the sequence 2, 8, 3y plus 5. Find the value of y if the sequence is arithmetic, and then find the value of y if it's geometric. So since we don't know what the third term is, we don't know if it's arithmetic or geometric anyways, but if it is arithmetic, then we would have to add 6, which means we would have to add 6 here to get the next one. So on Part A, if we take 8 plus 6, we should get the next term 3y plus 5. And so that would be 14 equals 3y plus 5. Subtract 5, divide by 3, and y would be equal to 3. So if it is arithmetic, then y would have to equal 3. And if you look, that would be 3 times 3 plus 5, or 14. And so that makes sense, because you'd have to add 6 to 8 and get 14. Now on part B, if it's geometric, we have to multiply by 4. So 8 times 4 should equal 3y plus 5 if it is geometric. So that would be 32 equals 3y plus 5. Subtract 5 is 27. Divide by 3. And y is equal to 9. And so for it to be geometric, y would be equal to 9. 4 times 8 is 32. So if I do 3 times 9, that's 27 plus 5 is 32. Question 112. What is wrong with the argument shown in the flowchart below? What assumption does the argument make? So in the first level here, we have monkeys like bananas. And then that goes to Sarah is a monkey. And on the second one, we have Sarah likes bananas. And then that goes to Sarah is a monkey. So the problem with this is that when it says Sarah likes bananas and then it goes to Sarah is a monkey, then we are assuming that everyone who likes bananas is a monkey. So that's in terms of the assumption that is made here. And so we would have to switch these around. But Sarah likes bananas, once again, implies that Sarah is a monkey, which means everyone would be a monkey. So that's what is wrong with the argument. Question 113. Camellia decided to find the height of the Empire State Building. She walked 1 mile away, 5,280 feet, from the tower and found that she had to look up 15.5 degrees to see the top. Assuming Manhattan is flat, if Camelia's eyes are 5 feet above the ground, how tall is the Empire State Building? So let's go ahead and get a sketch here. Here's our lovely building. And here's our lovely person. And they are 5,280 feet away from the building. Looking up at the building, it's 15.5 degrees. And this distance right here, or from her eyes to the ground, is 5 feet. And so we need to figure out this distance of the height and be able to add 5 feet back on to figure out the total height of the Empire State Building. We can use our tangent ratio to figure this out. Tangent of 15.5 is equal to delta y. And remember, delta y is the side opposite that angle, which is over here. So that's h over delta x is 5,280. Don't forget this is a ratio. So we can plug in tangent of 15.5 in our calculator. Make sure you are in degrees. And you get 0.27732 approximately is equal to h over 5,280. Multiply both sides by 5,280, and we'll get 5,280 times 0.27732. Or if you use tangent of 15.5 exactly, you'll get a more accurate answer when you go to plug this in. So we will say h is approximately, we'll round it to the nearest whole number, 1,464 feet. But don't forget, we need to add on that extra 5 feet where her eyes were located from the ground. So we add 5 feet, and that's 1,469 feet tall for the Empire State Building, and once again, approximately based on the approximation of tangent of 15.5. And so make sure you answer the question fully. Question 114. What are the possible lengths for side ML in the triangle below? So remember the triangle inequality theorem, and just kind of pretend on opening this triangle all the way up if you possibly could. So you would add 4 and 10 together to get a maximum value of 14, but a little less than that. Or you can pretend on taking the 10 and swinging it all the way down here, and then that would make 6 as the smallest. But the possible lengths would be anything greater than 6 and less than 14. So 6 and 14 would just make a line, so we have to go greater than 6 or less than 14, and then this would also be in inches, so let's make sure we label that as well. And this is side x that we're talking about. Question 115. Find the values of theta and alpha in the diagram below. State the relationship you used. So we have two parallel lines here. You can see that by the arrows. The other two lines are not parallel. So this angle and this angle, if we're looking at the right ones, those would be the same. That would be your alternate interior angles. And then 112 degrees and this angle are supplementary. So we could say that 180 degrees would be equal to 112 degrees plus theta. And so therefore theta would be equal to 68 degrees, which means if this is 68 degrees, then this down here has to be 68 degrees. For alpha, these would be right here and here would be corresponding angles, which means they are congruent. So alpha is 85 degrees. And don't forget, it does say to state the relationship, so I used alternate interior angles for the theta and also the straight angle. And then for alpha, I used corresponding angles.